All right, so this is the second section of the 4.4 notes. We're working with isosceles triangles. So I went ahead and I made myself a little cheat sheet here just because I knew I would be dealing with isosceles triangles this whole way through, and I wanted to make sure that I was very aware of what my rules were. So I gave myself kind of a generic example here of an isosceles triangle, and that way I can kind of keep track of what relationships I can assume and will be using as I go along. So in my diagram here, if you notice, I went ahead and I made two observations. One of the observations that I made, or not observations, but the notes I made, is that if an isosceles triangle does have two congruent sides, now those two congruent sides I marked yellow here. In this case, AB is congruent to AC. One other thing I'm going to mark is that that angle BAC, or in this case we could just say angle A, is the vertex angle. Okay. Angle A is the vertex angle. Now that might be important if I want to use particular parts of my theorems and information that I got on the first page of the notes. Now the other detail that's important here is that if those two sides are congruent, then the angles opposite of them, so in this case, AC is opposite angle B, and that is that AC does not in any way touch or form angle B. Angle B is formed by AB and BC. Okay, that angle B, the angle opposite of AC, and angle C, the angle opposite of BA or AB, are also congruent. Those are two statements that will get me through the majority of this problem, or of these problems. So first thing in the diagram that we have up here is we're going to want to go ahead and mark up any information that we have. Now in this diagram they tell us that for both of these problems BC is congruent to AC. So I'm going to go ahead and say, well, BC, I'm going to give 1 mark, and AC, I'm also going to give 1 mark. And because I like color and I think it's very helpful, I'm going to go ahead and mark up my diagram here as well. And highlight those two sides that I know are congruent. Now based off that, I can make another observation. So if I look here, I see that, well, AB and AC were congruent. Okay? The letters are different, but that's okay. Okay? Well, they're opposite angles. So in this case, angle 3 was congruent to the other opposite angle. So angle 4. Okay, and I can use another highlighter here, different color, to kind of accentuate that fact. Okay. All right. And in fact, I'm going to go ahead and erase those marks just because I think it's starting to clutter up my picture here a little bit. Just keeping in mind that these opposite, both of these angles are opposite congruent sides, so I know they are congruent. So now whatever information I do put in here, I know that these relationships will hold true for all of the problems. So for the first problem, they give me the measure of angle 4, and they tell me that that is 65 degrees. Well, if the measure of angle 4 is 65 degrees, then I know the measure of angle 3 is, hopefully you got 65 degrees because they are congruent. Now it asks me to find the measure of angle 2. I'm going to set my cheat sheet aside here for a moment just so I have a little extra room. Okay. Well, I know 2 angles of the triangle, but I don't know the third. So what I can write is I know that angle 2 plus angle 3, the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 must be equal to, well, the 3 angles of a triangle are always 180 degrees when you add them together. So now I can substitute in what I know. I don't know the measure of angle 2, but I do know that the measure of angle 3 is 65, and the measure of angle 4 is also 65 degrees. That's equal to 180 degrees. So the measure of angle 2 is equal to 130 degrees, or sorry, plus 130 degrees. I'm just adding those up. Is equal to 180 degrees. I'll subtract 130 from both sides. The measure of angle 2 is equal to 150 degrees. Now, I know that if this is 150 degrees, well, what relationship do angles 1 and 2 have? Well, angles 1 and 2, hopefully you've gotten, they form a straight angle. Therefore, I know that the measure of angle 1 plus the measure of angle 2 must equal 180 degrees. Now, I know that the measure of angle 2 is 150 degrees. I don't know the measure of angle 1. That's what I'm trying to find. And I get that that's 180 degrees. Subtract 150 from both sides, and I get the measure of angle 1 is equal to 30 degrees. Now I'm going to go ahead and erase all of that information from here for now. And the reason I'm erasing it, and keep my marks there, is because I'm going to move on to the second piece, and the information about the angles changes in this problem. Okay, I'm going to get some extra scratch work just so I have plenty of room. Now in this one, they tell me that the measure of angle 1 is equal to 140 degrees. Now, one of the pieces here is that there actually is a theorem that I'm going to use for these two, but we'll get to that in a second. We can use the, or you could use the exterior angle theorem, meaning that angle 3 plus angle 4 is equal to angle 1 that theorem is very useful, but at the same time we can certainly get there without it. So measure of angle 2 plus the measure of angle 1, we had already said needs to equal 140 degrees. So the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. I apologize. Those are supplementary. They're a straight angle. Measure of angle 1 then is 140 degrees, as is given, plus the measure of angle 2 equals 180 degrees. Now, I subtract 140 from both sides, and we're left with the measure of angle 2 is equal to 40 degrees. Now I run into an issue. I have three angles here, but 2 of them are unknown. Now, we can go ahead and just make our initial statement that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees, meaning that this angle plus this angle plus this angle, they form a triangle. They must be equal to 180 degrees. Now, if I fill in what I know and don't know, well, I know the measure of angle 2 is 40 degrees, plus the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. I don't know the measures of angles in 3 and 4, but what I do know is that they are congruent, meaning that the measure of angle 3 is equal to the measure of angle 4. Okay? And so there's a couple ways you could do this. I find using a variable can actually be very useful in a problem like this. So if we simply state that, well, if angle 3 is equal to x, then I know that angle 4 is also equal to x. Well, then I can replace this here. The measure of angle 3 I said is equal to x. The measure of angle 4 is also equal to x. So if I find out what x equals, then I'll know what the measure of angle 3 is. It's equal to x, and the measure of angle 4 is. It's also equal to x. Now, I can do, if I combine like terms, I get 40 plus 2x is equal to 180 degrees. Subtract 40 from both sides. Cancels, and we get 2x is equal to 140 degrees. Divide by 2 on both sides, and we are left with x is equal to 70 degrees. Now I know angles 3 and 4 are congruent, meaning that if angle 3 is 70, and I defined that as being x over here, then angle 4 is also 70 degrees. Right? Now moving on to the next pieces, we're going to have to make similar claims in these problems. So one of the first things I'm going to do is I'm going to go ahead and move up, and I'm going to put my cheat sheet back up. Now you can rotate your paper around, whatever orientation works to make you understand the problem. So in this problem, the initial statement is that I know that this side here is congruent to that side there. Well, what that tells me is that this angle, the angle opposite of one of my sides, must be congruent to that angle there. Notice how both of the pictures look very similar. This is a trait of every single isosceles triangle. Now that I have it marked up, one thing that I can do is if I know that these two angles are congruent, then if this one's x, you guessed it, that one also has to be x. So in this case, I see here that I have 3 angles, so let's go ahead and add them up and set them equal to 180 and see if we can solve. If we can't solve, we'll have to see if we can get additional information. But in this case, I see that I only have one variable, x, and I can solve. So I combine together like terms. 2x plus 30 is equal to 180 degrees. Subtract 30 from both sides. 2x is equal to 150 degrees. Divide by 2 on both sides, and I get x is equal to 75 degrees. Now before we put our final answer down, we do want to verify that that's what they were looking for in the first place, and it does. It says here that we are trying to find is what x equals, and in this case x would equal 75 degrees. Now you can double check your answer in that if x equals 75 degrees, then I can write 75 degrees here, 75 degrees here. Well, then 75 degrees plus 75 degrees plus 30 degrees should equal 180. Well, 75 plus 75 is 150 plus 30 is equal to 180, and I think at this point we can go ahead and verify that that is in fact a true statement. Now moving along to the next problem. We're going to do the same thing. We're going to take a look at our cheat sheet here. Well, in this case, I have 2 angles that are congruent. Well, if I go back to my notes, because this isn't the same, in this one and the one before, they told us that 2 sides were congruent. That told us that there was an isosceles triangle. But if I go back to my notes, I see here that Theorem 4.2 states that if 2 angles of a triangle are congruent, then the sides opposite are congruent as well. So for example, in the picture here, hopefully you had something that looked like this. Well, that angle is opposite this side, so this side must be congruent to the side opposite the other congruent angle, this side right here. So that being known now, well, I can go ahead and take a look here. I'm going to actually rotate my paper because I want it to line up with my cheat sheet. A lot of times looking at a problem sideways, okay, can actually be a benefit because it will be more familiar to you. It'll look more like what you're used to seeing. Okay? So in this particular problem, what they tell us is that this angle is congruent to this angle. Therefore, I know that the side opposite one angle, this one, must be congruent to the side opposite my other congruent angle, this one right over here. Well, now that I know that those are congruent, I know that congruent sides here will have equal measures. So I know that 2x minus 4 must be equal to my other congruent side, x plus 5. Let's get the x's on the same side of the equation by subtracting x from both sides. So we get x minus 4 is equal to 5. Then I'm going to add 4 to both sides, and I get x is equal to 9. So x equals 9 is the solution for this particular triangle. Now, for the next piece, we have that we have 2 angles, but we don't have the third. Now, looking at this problem, I immediately notice that I do not have 2 equal sides and do not have 2 equal angles. But you need to be careful because it's not necessarily what you need to solve the problem. And in this particular case, they just want to know the value of x. Well, they do give me 2 different sides, or two of the 3 angles. Well, I know that 62 degrees, the first angle, plus 56 degrees, plus x, well, any 3 angles, interior angles of a triangle, must sum to 180 degrees. In this case, you don't need to know that they're isosceles. What we're going to find is they most likely are isosceles, but the information they gave us, it's not necessary. I add these 2 up here, and I get 118 degrees plus x is equal to 180 degrees. If I subtract 118 from both sides, what I find is that x is equal to 62 degrees. Meaning that this is an isosceles triangle, but based off the information that they're giving us, we do not even need to do anything farther with this. Now, I'm going to go through this proof here, but I'll leave the last proof to either do on your own, or we will go over it in class. So, for this particular proof, they give us certain pieces of information. First, they give us that angle 1 is congruent to angle 2, so I can go ahead and mark that down. Angle 1 is congruent to angle 2. That was the first piece of information. That's a given, so I'm actually going to go over and kind of take a look at some of the statements that they're making. That's definitely the thing that we would mark down first. We're going to mark down our given because they don't give us any other information. Now, what we're trying to prove here is that AB is congruent to AC. Okay, so the yellow is what we are trying to prove. So now I'd like you to take a look at this for just a moment because we need to come up with a game plan. The only piece of information they gave us was that we have 2 angles that are congruent. Now, a strategy that you can follow is to simply look for any other congruencies that might exist. Now, you don't need to necessarily even be thinking about what you're trying to prove in this case. Now, looking at these, I don't have any parallel lines. I don't have any congruent lines. So the only assumption I think I can be making is that I should be looking for any sort of supplementary angles or congruent angles, maybe through vertical angles or anything like that. And if you go through that thought process, you look for the easy congruencies like vertical angles, I can see that 1 and 3 are vertical angles. I can also see that 2 and 4 are vertical angles. Well, I do see that that is an option here. I'm going to go ahead and put a tentative 2 there to to make sure that, but I will double check to make sure that's the right process. Well, at this point, if you think back to the problem that we did up here, well, if we know that these two angles are congruent, then we know that the sides opposite of those two angles are also congruent. Well, that's what we were trying to solve. So in this case, we know that 3 is congruent to 4 is a statement we need to make. Now we make that statement through substitution. Okay. We know that 2 is congruent to 4, or first off, we know that 1 is congruent to 2. So if 2 is congruent to 4, then I can replace 2 with 4, which is what we have right up here. And same thing here, if I know that 3 is congruent to 1, then instead of 1, I can replace it with 3. Well, from there is where we got to the point that we had AC is congruent to AB, okay? And that was in fact theorem 4.2. And that was the theorem that we went over just a moment ago, the converse of the isosceles triangle theorem, stating that if two angles of triangles are congruent, then the sides opposite the angles must also be congruent. The last proof, if you'd like to attempt it, you can certainly do your best, but this is one that I would prefer to go over with you in class. If you have any questions about anything that was done, I will be going over these notes in class as well, but if you've completed them, then you'll have the opportunity to start the homework.